There are three types of muscles, which include the skeletal muscle, cardiac muscle, and smooth muscle. The skeletal muscle tissue's purpose is to move the body, so when the skeletal muscles contract and shorten, it pulls on the tendon that is attached to the muscle and the bone, which results in the bone moving. An example of this is when the bicep brachia contracts. It pulls on the tendon that is attached to it, but also attached to the radius, which causes the radius to be pulled to the shoulder, referred to as flexion of the arm at the elbow. This is known as a voluntary movement, so you as the individual control the movements your body makes. Voluntary movements are controlled by the central nervous system. The structure of the skeletal muscle is that it is bundled up with hundreds and thousands of muscle fibers and surrounded by a connective tissue covering called the epimysium. Skeletal muscles can either work aerobically or anaerobically to create energy during respiration. For instance, the skeletal muscles in the leg, so the quadriceps, hamstring, gastrocnemius, and tibialis anterior, can work aerobically during an endurance race or anaerobically during a 100-meter sprint race. However, the cardiac muscle tissue is a specialized type of muscle tissue and is only located in the walls of the heart. It is responsible for pumping the blood around the body and then to the working muscles through slow contractions. This is important as it transfers the oxygen through the body by red blood cells. This blood with oxygen in it allows the skeletal muscles to work during a contraction. An example of this would be a rugby player suddenly having to contract the muscles in his or her leg to sprint for the ball. One of the properties of the muscle is that it contains a lot of cells. It is an involuntary muscle and works aerobically for respiration, so it's controlled by the automatic nervous system. One of the structures of the heart is that the sinoatrial node is the heart's natural pacemaker. It is situated in the upper walls of the right atrium. The electrical impulses happen there which control the rhythm of the heart, so they establish the contractions that pump the blood out of the heart to the rest of the body. Smooth muscle tissues are flexible as they are fit for bodily functions, so they change. They produce long, slow contractions as well. An example of this is in the stomach, as it changes shape all the time due to digestion. It has to push fluids and solids through hollow tracts. The muscle lines the organs such as intestines, the bladder, the kidney, and the stomach. The muscle is full of cells called myocytes that can tense and relax as well. This muscle works involuntary, so it's controlled by the autonomic nervous system and uses the aerobic system for respiration. The smooth and skeletal muscles are found in many places throughout the body. This is in contrast to the cardiac muscle, as this type of muscle is only found in the heart. Likewise, the cardiac and smooth muscles are controlled by the autonomic nervous system, whereas the skeletal muscle is controlled by the central nervous system. Another comparison is that the smooth muscles respire using the aerobic system, compared to the skeletal muscles which respire using the aerobic and anaerobic systems. Also, the muscle fibers in the smooth muscles are smaller than the muscle fibers in the skeletal muscles. A similarity is that all of the muscle types are binded together with cells and connective tissue. There are many functions that each muscle type has. Digestion. The smooth muscles expand and respond to how far along in the process of digestion you are. They push fluid and solids along the digestion tract. The muscles respond by the autonomic nervous system because they work without you having to think about it. These muscles are extremely important to help the body perform a variety of crucial tasks. The smooth muscles can be found in many parts of the body, such as in the walls of hollow organs, which include the stomach, bladder, kidney, and intestines. Smooth muscles determine the flow of blood in the arteries. Circulation. The most important muscle for circulation is the cardiac muscle. The cardiac muscle is located in the walls of the heart. It causes slow, regular contractions subconscious to your body. Therefore, it is controlled by the autonomic nervous system. It pushes the blood through the chambers of the heart and out through the arteries. This allows circulation of the blood to the skeletal muscles, where the glucose and oxygen in the blood is used for aerobic respiration. The cardiac and skeletal muscles have to respond to each other. This means that in a 1,000-meter event, your skeletal muscles require more blood for aerobic respiration. This means the cardiac muscle needs to contract more often to provide the blood containing oxygen and glucose for the working skeletal muscles. Motion. The skeletal muscles contract in pairs to pull on the bones which are connected by tendons to produce movement in the appendicular skeleton. The central nervous system controls the contractions of the skeletal muscles. In addition to this, skeletal muscles can work aerobically or anaerobically. For example, when executing a kick in football, there is extension of the leg at the knee. As when the quadricep contracts and shortens, the tendon that is attached to the tibia and quadricep allows the leg to extend at the knee, enabling the athlete to kick the football. Stability. One of the main functions of the muscles is to create stability. This is a voluntary movement that can either hold the body in position, so it is controlled by the central nervous system with skeletal muscles. For example, in a handstand. However, the stability of one section of the body can then allow the movement of another. For example, a punch in boxing. If there is no stable base, then it is impossible to complete the action. That's why your core strength is very important, as it keeps a stable base so that your appendicular skeleton can perform certain motions, like a baseball swing. Heat production. Muscle contraction in the body, controlled by the skeletal muscles and the central nervous system, allow the temperature in the body to increase and decrease. For example, when shivering, the contractions allow the muscles to warm up. Vasoconstriction decreases the flow of heat to the skin, so allows you to keep temperature in your body instead of losing heat by perspiration. When the body is too hot, though, during physical activity, the body loses heat by the process of convection. This is important as you don't want the body to overheat, as this could be dangerous and cause other problems within the body, such as fainting. The origin is the segment of the body that doesn't move during a muscle contraction. It is the fixed attachment point. However, it is usually proximal to the insertion. Whereas during muscle contraction, the insertion is the attachment site that does move. Multiple examples of this would be in a variety of sports. For instance, with a gymnast, when he or she performs plantar flexion of the ankle, the origin is the femur and the insertion is the calcaneus. So when the gastrocnemius contracts, it causes the calcaneus to move, giving the action of plantar flexion. Also, within a sport like rugby, when the athlete is in preparation to kick the ball, there is flexion of the leg at the knee. So in this case, the origin is the hip and the insertion is the fibula. So when the quadricep contracts, it causes the fibula to move, resulting in the movement of flexion of the leg at the knee. Type 1. Type 1 muscle fibers are known as slow-twitch, oxidative muscle fibers. These produce a low force and speed of muscle contraction. However, they can keep contracting for long periods of time. So they produce their energy by working aerobically, which means they have a low fatigue rate. This is useful for a marathon runner in an endurance event. This means that the oxygen that is supplied to the working muscles is constant over long periods of time, which result in the athlete being able to keep contracting these muscles so that they can complete their marathon. The reason the muscle fiber is red is that it contains a large amount of oxygen. Type 2B. Type 2B muscle fibers are fast glycolytic muscle fibers. These produce a very high force and speed of muscle contraction. These are white muscle fibers and produce their energy by working anaerobically. However, these fibers have very low levels of endurance, so they can't contract for long periods of time, so their fatigue rate is very high. These muscle fibers are useful and suitable for 100-meter sprinters. This is because these muscle fibers fatigue at a high rate because there is not many oxygenated red blood cells being supplied to the working muscles. This is why the muscle fibers are white. In fact, they are starting to fatigue just after 10 seconds of anaerobic work, which is perfect for a sprinter because the 100-meter race is completed within or just over 10 seconds. In addition, the contraction speed from the muscle fiber is very high, which aids the sprinter, as the more fast-twitch muscle fibers they have, the more speed they generate, resulting in them being fast and potentially beating their opposition. Type 2A. Type 2A muscle fibers have the characteristics of both type 1 and type 2 muscle fibers. They are known as fast oxidative glycolytic muscle fibers, as they produce a high force and a moderate speed of contraction, but can continue to contract for medium lengths of time. So they produce their energy by working anaerobically and aerobically. This is particularly suited for an 800-meter runner. This is because the race isn't as long as a marathon, so the athletes don't require a high demand of oxygen produced by slow-twitch oxidative muscle fibers to keep their muscles contracting, but they do need a moderate amount and definitely more than a sprinter needs. But the athlete also needs an element of fast glycolytic muscle fibers, as their muscles have to contract quickly in order to generate the speed, as the race is over within 3 minutes. There are differences and similarities of the characteristics and properties of the different types of muscle fibers. Slow oxidative and fast glycolytic muscle fiber characteristics and properties are the polar opposite of each other. Slow oxidative muscle fibers have a slow speed contraction, but their fatigue rate is low, meaning that the muscle fibers can keep contracting for long periods of time. This is because they are red muscle fibers that work and respire aerobically. So this results in more oxygenated blood being supplied to the working muscles over long periods of time. So the athlete can keep working at the same intensity throughout the duration of the race or event. So this muscle fiber is perfect for an athlete that is doing the Tour de France. In contrast to this, fast glycolytic muscle fibers have a very fast contraction rate but fatigue very quickly. This is because they are white muscle fibers and the oxygen that is supplied to them is little, as they work and respire anaerobically. This is useful for a sprinter, as their event is over in under 10 seconds. There are similarities between both fast glycolytic muscle fibers and fast oxidative glycolytic muscle fibers. This is because both of these muscle fibers can work anaerobically. Likewise, the fast oxidative glycolytic muscle fibers also have a similarity with the slow oxidative muscle fibers, as these can both respire aerobically.